Good morning, sir. Good morning to everyone. My name is Leela Kalyani. I am from CSE first year BTech. Subject name Basic Electric and Electronics. Today my topic is about the XOR, XNOR gates, truth gates. Today my topic name is XNOR, XOR gated truth gates. Next slide. Introduction to logical gates. Logic gates are fundamental building blocks of digital circuits. They perform basic logical functions that are essential for a digital computation. Understanding these gates is a circular for designing complex electronic systems. Next slide. Next slide is about the definition of XOR gate. XOR is also known as exclusive OR gate. Outputs true only when the number of true inputs is odd. Its truth table shows that the output is true for input combination of 1, 0 and 0, 1. XOR gates are commonly used in applications such as arithmetic operations and error detection. Next slide. Next slide is about the truth table for a XOR gate. The truth table for an XOR gate has two inputs A and B. The output is true 1 for the input pair 0, 1 and 1, 0. If the output pair 0, 0 and 1, 1, the output is false is 0. Here is the representation of a truth table of a XOR gate. Next is the diagram of XOR gate. It is represented as two inputs A, B, A, B, Q. If A 0 and B 0, Q equals to 0. If A 0, B equals to 1, then Q equals to 1. If A 1, B 0 and Q equals to 1. If A and B equals to 0, then Q equals to 0. Next slide is the definition of a XNOR gate. The XNOR gate is also known as the exclusive OR gate. Is the complement of the XOR gate. It outputs true only when the number of true inputs is even. XNOR gates are often used in equally checking and digital signal processing. In XOR gate, the outputs are only when the number inputs is even. In XOR gate, when the outputs true only when the number inputs is odd. Truth table of an XNOR gate. The truth table for an XNOR gate is also has two inputs A and B. The output is true 1 for the input pairs 0, 0 and 1, 1. The output is false 0 for the input pairs 0, 1 and 1, 0. Next slide is about the XNOR gate. It is representation. It is the truth table of the XNOR gate. If input A 0 and output B 0, then output 1. If input A and A is equals to 0, if output B equals to 1, then output is 0. If input A 1 and output 0, if input A equals to 1 and our input B equals to 0, then output equals to 0. If input A equals to 1, then output B equals to 1, then the output equals to 1. This is the representation of XNOR gate of the truth table. Next slide is about the logical expression for a XOR and XNOR. The XOR operation can be expressed as A plus B equals to A and not B or not A and B. The XNOR operation can be expressed as A lies B equals to A and B or not A and not B. These expressions highlight the fundamental logical relations of the gates. Then the applications of the XOR gates. XOR gates are widely used in digital circuits for arithmetic operations like addition. They are also utilized error detection and the correct algorithm. Additionally, XOR gates play a key role in cryptography systems for data security. Here is the basic digital logical gates. Here is the representation of a XOR gate. Next slide is about the XOR gate of the truth table. Next is key differences between XOR and XNOR. The primary differences in their output condition related to the number of true inputs. XOR outputs true for an odd number of true inputs, while XNOR outputs true for an even number. This fundamental reduction makes each gate suitable for a different applications. Next slide, conclusion. Understanding XOR and XNOR gates is vital for a digital circuit design. These gates help achieve complex logical operations in electronic systems. Mastery of these concepts is essential for anyone studying or working in electronics and computer engineering.